Okay, so we'll look at exponential and linear growth in SAT. So let's look at the first example. Here we have a graph, and basically what's happening here is that it's curving, right? You see the curve? If it's curving, then that means it's an exponential graph, right? It'll be exponential. Basically what's happening is that it can either be an exponential increase or an exponential decrease. So if it's decreasing, if it looks like this, and if it's curving, if it's decreasing, it's going to be an exponential decay, right? That means an exponential decrease. So here's what that looks like. Here's what the equation looks like. You have A, which represents the initial value. You have A, which is initial or the starting value. And then you have X, which tells you how much is going to increase or decrease, right? So for example, if you have a graph that looks like this, let's say this is 10, this is 1.2, and this is t. Now what's happening here is that 10 is going to be the initial value, and it's going to be a starting value, and it's going to increase by 1.2. So if it's 1 point something, that means it's going to be an increase, right? If it's 0 point something, it's going to be a decrease. So for example, if I say 1.3, that means a 30% increase. If I say 40%, if I say 1.4, that means a 40% increase, right? If I say 2.2, that means 120% increase. Basically, what you have to do is you have to minus with 1. And similarly, if I say, for example, let's say 0.9, that means a 10% decrease. If I say 0.75, that means a 25% decrease, right? By the way, if you want more clarification on this, you can watch the previous video. I've explained this there. So going back to the example, if I have y is equals to 10, 1.2t, this tells me that 10 is going to be the starting value. It's going to start from 10, and then 1.2 means it'll increase by 20%. So it's a 20% increase, meaning it's going to look something like this. We will start at 10, and then it's going to increase by around 20%, right? So it'll look something like this. So that's what an exponential graph looks like. So here's another example. In this case, it's 400 being the starting value. So it starts from 400. Let's say this is 400. And then it's 0.6. 0.6 means it's going to be decreasing by 40%. So it's a 40% decrease. So it might look something like this. Something like that, right? So it's an exponential decay or decrease. And then we have linear relationships. So if it's a straight line, it is going to be linear, right? So it's a constant increase or a constant decrease. The equation looks like this. So you have y is equals to mx plus c. So if you have an equation that looks like this, then it is most definitely a linear relationship. Whereas if you had y is equals to a b to the power of t, this represents an exponential relationship. So here's an example. Let's say you have this equation. Now in a linear equation, this is what it represents. You have y is equals mx plus c. M represents the increase or decrease, the linear increase or decrease, and then c represents, again, the starting value. The starting or the initial or the y-intercept. So in this case, we have that the m in this case is going to be minus 10, and c will be 50. So it'll start from 50. Oh, I have it here, I think. It'll start from 50, and because it's negative 10, it's going to decrease by 10. So it starts from 50 because c is 50. So c is 50 and m is minus 10. It'll start from 50, and then it's going to decrease by 10 because it's negative 10. So every time it's going to decrease by 10. So after one increase in x, it's going to decrease by 10. So this is going to be around 40, right? And then it's going to be 30, and so on, right? It'll look something like this. So every time it's going to be a 10 decrease for every increase in 1 in t. So we have the different types of association. We have a negative and a positive association. So if it's decreasing, it can be a linear decrease or an exponential decrease. If it looks like this, it is decreasing, which means it's a negative association, right? If it's a linear curve, a linear graph, it'll look like this. If it's an exponential curve, it might look something like this, right? So this is also a negative association for an exponential curve. By the way, this is a scatter plot, so this is how you determine the relationship between two different variables. You have final exam score and you have number of absences. So this is drawing the relationship between these two, and we can denote that as the number of absences increases, the final exam score decreases. This is based on actual data points, right? So this represents an actual experiment that was conducted. So when the data points are close together, we can say that this is a strong negative association. So for example, if the dots are close together, something like this, you would say that this is a strong negative association. However, if you have a relationship that looks like this, say for example, it's still decreasing, which means it's negative, but it's going to be a weaker association because the dots are much farther apart. So that's a weak association. All right, next. So this is going to represent a positive association that is quite strong because the dots are close together. They're not that far apart, so it's pretty strong. And then we have questions. So question 1, it says the initial population was 20 and then it grew to 25 after the second year. So we need to show which one represents the relationship. It says the growth is considered to be exponential. If it's exponential, it should look like this. That is the equation, which means it cannot be A because that's linear, and it cannot be D. So it's either B or C. Now to find the equation, we have to check the values. So we know that the initial was 20. It starts from 20, which means A is 20, and then we need to find the rate of increase. So it goes from 20 to 25. So to find the increase, we need to check the percent increase. So the percent increase is the new value minus the old value divided by the old value. The new value is 25, the old is 20, divided by 20. So this is going to give you 5 over 20, which is 1 over 4, which is also 0.25. So it's going to increase by 25%. It's a 25% increase. So if it's a 25% increase, you can write that as 1.25. That means a 25% increase. So that's going to be B. Next one, it says we have a population of pandas was 100 and it grew to 125 in the first year. It says the relationship is linear. So that means it cannot be B and it cannot be C because that's exponential, and it cannot be D because that's quadratic. So that has to be A by process of elimination. Then question 3, it says the population has been decreasing by 6% every 4 years. If you see the word every, that means you have to divide by 4, in this case by 4, right? So every means divide. So it says at the beginning of 2015 it was 14,000, and then it is going to decrease over time, and because it's decreasing by 6%, that means it's going to be exponential. It's an exponential decrease. If you see percent, it's exponential. And an exponential equation looks like this. We know that the initial value is 14,000. That means A is 14,000. It's decreasing by 6%. The way you write decrease by 6% is 100 minus 6, which means 94%, which you can write as 0.94. 0.94 means a 6% decrease. So that's 0.94. And then because it says every 4 years, instead of just writing t or x, you write t over 4. So that means every 4 years. So it starts with 14,000. It's going to decrease by 6% every 4 years. So that's going to be D. All right, next. It says which scatterplot shows the strongest positive association. Because it says positive, that means it has to increase, which means it's either A or C. It cannot be B because there is no relationship in that, and it cannot be D because that's decreasing. And because it says the strongest, the dots have to be very close together, which means it has to be C. Right? That's why. Question 5, it says Jamie owes Tina some money and decides to pay her back in the following way. Tina receives $3 the first day, 6 the second, 18 the third, and 54 the fourth. We need to describe the relationship between time and the total amount over these 4 days. So it goes from 3, 6, 18, 54. Now this cannot be linear because it doesn't increase by the same amount every time. It is increasing, but it's not linear. If it was linear, it might look something like this: 3, 6, 9, 12, because that's a difference of 3 every time. So this is going to be exponential, and it's going to increase. So it's an exponential growth. Next, it says Albert has a large book collection. He decides to trade in 2 of his books. He trades in 2 for 1 new book. So he gives 2, and then he gets 1 each month. So overall, he's losing a book every month. Right? So we need to describe the relationship. Because it's 1 every month, that is going to be linear, right? It's not changing, it's always 1 every month, which means it's linear, and it's going to be a decay because it's decreasing. So decreasing linear. Question 7, it says the scientist counts 80 cells and finds that 1 splits into 2 new cells. So you have 1 cell, it splits into 2. Right, so it looks like this, and then this splits into 2 more, right? So something like this. That's the function, so that means it's exponential. Which of the following could be the values? So A is equals to CRT. So C represents the initial value, like AB to the power of X. C represents the initial. So the initial is 80. We start off with 80, and then it's going to double every time, right? 1 splits into 2, that means it's doubling. So the best way to write double is 2. So if you write 2, that means double. So if you write 3, it means triple. If you write half, that's going to be 1 over 2. So double means 2, and then it's to the power of X. So C is 80, and R is 2. C is 80, R is 2. That will be our answer. And then we have question 8. We need which of the following scenarios would result in linear growth. Linear means it'll increase or decrease by the same amount every time. So in the first one, it says the owner increases the square footage by 0.75% each year. If it says percent, it's usually exponential, so it cannot be A. In B, it says he increases the square footage by 5% each year. Again, that's going to be exponential. In C, it says the owner expands the store by 5% of the original square footage each year. So it says 5% of the original. So because the original is constant, that doesn't change, which means 5% of that will also remain constant. So for example, if the original was 100, if you find 5% of 100, that's going to be 5. And that doesn't change, it's always going to be 5. Whereas with the previous ones, with A and B, it's some percent each year, right? So if it's some percent each year, it's exponential. But if it is some percent of a fixed value or original, that's going to be linear, right? So if it is some percent of the original, it's linear. If it is some percent each year, that's going to be exponential, right? So it's going to be C, and then let's look at D as well. It says the owner alternates between adding 200 and 300 each year. So that means plus 200, and then plus 300, and then plus 200, and then so on. So that's not linear, right? That's not linear. So that means it has to be C.